Bismillahirrahmanirrahim. This is another video about magnetic circuits, and in this we'll be solving end chapter problem 1.6. Okay, so let's see the question. A ferromagnetic core with a relative permeability of 1500 is shown in the figure. So this is the core. Now let's see features of the core. First of all, note that all the widths are same. So 7 centimeter everywhere. Then we have two air gaps. One has a slot size of 0.07 and the other slot size is 0.05 centimeter. 400 turns is given, and because of the fringing effect, the effective area of the air gap is 5% larger. So I'll discuss this in the next slide. Next to next maybe. Current is given as 1 ampere, and we have to find flux in each of the left, center and right legs. So flux in this leg, center leg, right leg. Also we have to find the flux density in each of the air gaps. So flux density here and flux density here. Okay, so the first question, to find the flux in each of the legs. Now just keep in mind that as if we are trying to find the current in each of the leg. Flux in magnetic material is just like current in the electrical circuits. What all is given is, or we have to use, is the MMF, which is N into I. Here we can easily see it is 400 turns multiplied by 1. So if we know the MMF, we can find flux by MMF divided by reluctance, just like I is equal to V over R. This is the formula of reluctance we have learned earlier: the length of the core, area of cross section of the core, permeability of the material and permeability of air. So permeability of material is given as 1500, and we know the permeability of air 4 pi 10 raised to the power minus 7. If you don't know, you memorize it. Okay. So first thing we'll do is try to find the length, mid length, or the this, and I have shown it in 3 colors because there are 3 different regions: left region, right region and center region. So when we draw the magnetic circuit, it would be something like this. R1 is for the green line of the core material, reluctance of the core. Then G1 is written A1, it should be G1. G1 is the air gap reluctance due to the air gap. Similarly, right hand side, R2 is the reluctance of the core, and Rg2 is the reluctance of the air gap, and R3 is the reluctance of the midline, and this MMF can be shown like a voltage source. And just for our ease, I have named them. This arm is called L1, its length. Length of the air gap is Lg1, length of gap. Then L2, length of gap is Lg2, and this length is L3. Okay, so let's find all the reluctances. These are the parameters we have already learned. So R1 first. For that we have to calculate L1 and A1. Now L1 is starting from this point is L1, this. So it is, you can see we are starting from half of 7.5 up to this point, so it is 3.5, so 3.5. Then we have 30, and then we have half of 7.5, 3.5. Similarly on this side and similarly on this side. Just copied and all the three. The total length is 111 centimeter. Converted into meter is 1.11 meter. All dimensions must be in meters. Okay, now the area of cross section, the width is 7 centimeter and the depth given here is 7 centimeter. So width into depth, 7 into 7, 49 centimeter square, which is equal to 0.0049 meters square by dividing by 10,000. And now we are ready to calculate R1. So plugging in the values, all these. So this is the value of R1. Now we'll calculate air gap reluctance. For that we need to find the length of the air gap. Now you can see this slot length is 0.07 converted into meter. Similarly, now the increase due to fringing. Now this is 0.05 is the area up to this point, But he's saying that there will be 5% increase due to fringing. So when we are in the air gap, the magnetic line of force try to bulge away. So the area here increases, and that increase is by 5%. So for 5% we write 105 divided by 100. Therefore area of the air gap is 0.0051 meter. And now with these two we can find the reluctance of the air gap. And remember, since there is no metal, therefore phi r we cut and simply mu naught and the area. So this is the reluctance of the air gap. Now reluctance of the right hand side, since the dimensions are all same, and therefore the reluctance of the right hand core material is also same. So just instead of calculating, we can just copy R1 here, it will be same value. However, the reluctance of the air gap right hand side will be different because this length is different. Here it was 0.07, here it is 0.05. So length is different, area remains same as we calculated here, so 0.051, and plugging in the value, this is the reluctance of the right hand side air gap or R2. And now what is left is R3, the middle one. Middle one length is again same length as we have here. So 3.5, 30 and 3.5, 37 centimeters, 0.37 meter. Area is same as we had calculated for the other arms. And so R3, putting in the formula, this is R3. So now we have found all the 5 reluctances. Just shown here, all the 5 reluctances. Now we'll try to simplify. So just adding these two here and these two here. And now we are interested to find the total reluctance. So for that you can see these two are in parallel, and the parallel comes in series with R3. So we can say R total is R3 plus these two arms in parallel, which can be solved, and the answer is 146.39. So this is R total. So our circuit will now look like this, MMF and R total. And if we know the value of MMF, which we know it is 400 into 1. So now just as if we have the voltage and we have the resistance and we need to find the current. So voltage divided by resistance is current. Same here, that the flux will be this one divided by the reluctance. Now again repeating the question, we need the flux in the left arm, center arm and right arm. So the center arm will have same current or same flux as the total flux, because this let's see, if I assume it to be current, then this current is dividing into two parts. So this is the total current. So this is also the total flux. So from here the total flux is phi center is equal to phi total is equal to MMF divided by R total, and this is the flux in the center. So center flux we had found, and now we have to find the flux on the left and flux on the right. So it is just like the parallel circuit where we find current in the two arms by current division rule. Exactly same thing will follow here. So by CDR, phi left will be the total current or total flux divided by total reluctance and multiplied by opposite arm. So we want to find here, then we multiply by the opposite arm. So this is the flux in the left side, and similarly flux on the right hand side. So all three flux we have calculated. So part A of the question is done. Now for part B, it's saying what is the flux density in each of the air gap. So flux density here, and we know flux divided by area is the flux density, and we also know that the area is increased here, so we have to use the increased area of the air gap. So flux density left is the flux left divided by area of the air gap, and similarly flux right is flux density right is flux right divided by air gap right. So I hope you have been able to follow this, and you will be able to solve similar questions by following all the steps that have been shown here. Thank you.